Hello everyone, welcome to this fourth part of the tutorial series that can help you to use the FitMulticell pipeline. In this part we will try to give an example about how you can use the FitMulticell pipeline on large cluster using parallel implementation that enable the FitMulticell pipeline to run on large clusters and on many cores. This script can be used on cluster that is using Slurm job management system, and so we have developed a bunch of batch scripts that can make the usage of the pipeline easier on these systems. I will put the repository that contain these batch scripts within the description of this video. So you will find many versions of the batch scripts within this repository. And also you will find a brief introduction about how to use it. So I will, for example, use the first version, which is batch large. So if you click on that folder, you will see many batch scripts. We will go through them now quickly. So the main one is submit job L, which will be the manager that will ask for all the computational resource and then distribute them within Redis master and Redis worker and within also the Python file. So if you click on it, you will find that this batch script is taking 6 arguments. The first one is the port, because we will connect between the worker and the Redis master through a specific port, and also n nodes will refer to the number of nodes that's going to be used for the fitting run. And also you can also specify the partitions, because in these large cluster system and HPC systems there will be usually multiple partition, and then you can specify to which partition you want to submit your job to, and then the time that needed for your job to execute, you can specify this also as an argument. And also the number of CPU per tasks, you can specify this as an argument. And also finally you can specify your Python file. So the first thing that will happen within this script, we will load all modules that is existing on the load module.sh file, and this is another file that you can customize based on your needs. Once your modules is loaded, then you can start submitting the Redis server. And here we will ask for one node for the Redis server, and all the instruction that is needed for the Redis server will be find here on this submit redis l.sh bash script. And then after that we will obtain the IP address of the node that has been assigned for the Redis server here, and then we will pass this IP address to all workers, as you can see here. So we have assigned one task per node, and then each worker will occupy one of these nodes, and then we'll use the CPU per task that has been assigned by the user, and will execute all instruction within the submit worker l.sh. And finally here we will also start the Python script that has been given as an argument for this main bash script. Okay, let's go back and see other bash scripts. For example, the load module.sh will contain, as I said, all the modules that you want to load within your cluster. Let's go back and see now the submit Python script. So this script will take the current path as an argument, the IP address, because we need to assign this or give this to the Python script, and also the port that is being used and the Python file. And then we will start the Python file, start executing the Python file within the selected IP and port address. Okay, let's also see how we are going to submit the Redis job. So it will take only one argument, which is the port and also the current path, and it will start your Redis server. And yes, this is something that you need to modify in your case. So I have here specify the location of the executable file of the Redis server. In your case, if you install Redis, or if Redis is already existing in your cluster, then you will have to modify this path and put the path that is suitable for your system. And let's go back and see the final file, which is submit worker, and how we will link workers to the Redis server. If you click on this one, you will see that it will require the current path, IP address, port, the port number, and the time needed for execution, and the CPU per task. And then again we will load all the modules that is needed, and we will start Redis worker. Also, you need to modify this. If you install the PyABC package, you will have this executable which is called abc redis work, and yes, you will need to identify the path for that and replace it with the current path here, which is the one that I have it on my system. And this abc redis worker will ask for some arguments, such as the IP address of the Redis server and the port address, the port number, and the runtime that this worker will be killed after that, and this will be given as an argument by the user, and the number of processes per task. Okay, with this we have finished explaining the bash script. Now what we will do is to go into the cluster and try to clone this repository and directly using it. Hello back. So now I am signed in onto my cluster where I would like to execute the FitMulticell example, and here I have created a folder called example fmc, and inside the folder I have two files. The first one is the Python script that I would like to execute, and also along with it the XML model, the model that I would like to parameterize. And you can find the model and the example in the documentation of the FitMulticell pipeline. The example is for a model that is concerning about cell motility. Try to do the parameter inference for two parameters of interest on that model. So I would like just to show you small changes that I have made into my Python script. So at the first, you would notice that I am taking some argument from the user. So when you execute the Python file, you need to give the IP address that is going to be used, and also the port number. Both are essential, and the IP address will be dynamically taken from the Redis master node or the Redis server node, and it will be given to the workers, and the port number will be taken from the user. Otherwise it will take the default port number, as you can see here. The second thing that I modify is when I initialize the model, I explicitly define where the executable of the Morpheus is going to be. So I have installed Morpheus locally into my directory within the clusters, and then I'm giving the binary file of the Morpheus for the argument executable. And finally, what I have done is to also select the sampler that is going to distribute the work among different workers. So this sampler can parallelize the work among a distributed memory system, so it can use more than one node within the parallelization process. So you can read more about this Redis sampler within the documentation of the PyABC package. So here I have import the Redis eval parallel sampler, and then here I'm giving it some of the arguments. For example, I am giving it the IP address that I have sent through an argument when I execute the Python file, and also the same for the port number. And then I have also assigned some of the additional arguments. You can read more about them within the documentation of this sampler. And once I initialize my sampler here, then I can specify it when I initialize the ABC object. So I would specify the sampler here, as you can see in this step here. And finally, everything, I think the rest of this file is similar to what you can obtain from the example within the documentation of the FitMulticell pipeline. Okay, let's go back. Now we have these two files. What I will do next is to clone the repository of the bash scripts that you can find the link to within the description of this video. I will go back and just clone it. It will be a fast process since the repository is does not contain many files. So now I have the file cloned into my local repository, so I can navigate into it, and then I will find different version of this batch scripts, and they are just different on how they treat or utilize the computational resource. So as I said before, I will stick with using this one, batch large, and then you can see here I have my different bash scripts as we explained them before. So now we are ready. We can start submitting the job. So here you can see that because I'm using, or within this cluster we are using the Slurm batch script, so I will submit a job using sbatch. Then I will define my account within the cluster. This might not be needed in your case, but in my case I need to define the account, and also you need to define number of nodes, the number of tasks that you need to initialize, and then the time, and then you will specify your batch script, which is the main one that we are defining here, submit job l.sh. And then here are the different arguments that you need to pass to this bash script. The first one is the port number, so I'm here selecting 4013, and then number of nodes, and the partition name that you need to submit this job to. So I'm sending this job to the batch queue, and also the time needed, or the wall time, maximum wall time for this job. And then you need to define here number of CPU per tasks. So I have here 48 cores per node. And finally you need to define your Python file. So I will modify this. Let me go back one step and try to copy the path here. So the path where I have my Python script, and then let's go back to where we were before. Okay, now we can now we can submit our job and give the full path to our Python script. And then goodbye. Now we are ready to submit our job. Once you click enter, then you will see that your job is being submitted, and you can check the status of your job. So my job is still on pending status. I will be back once the job start to be on running state, or when it's finished. See you in a bit. Hello again and welcome back. So now our job has been finished. Now if we look into the queue, you will see that our job is finished. And when we will look back, so let's go back to our bash script folder from where we submitted our job. And if we look into the folders, we will see there are some additional files, such as, for example, the Slurm output file, and the Redis output file, and the Python output file, and finally some outputs for each of the workers. For example, we can look into the Slurm output, and you will see that for each of the worker you will find the output of that worker, and then you will, for example, find how many simulation was executed by each of the workers, and that was in which generation. Then you will find the epsilon at the end of each generation. And if we go to the end, you will see that we have reached to the termination criteria, reaching to the maximum number of generation, which is I think it was 8. And then yes, so the job was executed successfully. And if we will go back where we ask the Python script to save the uh, fitting output, we will find our database test.db saved also, so we can move it back into our uh, remote computer and then visualize it and do additional diagnostic on that run. With that, I would conclude this part. Thank you for listening and see you in the next part. Bye.